Okay, so now we're going to be getting into solving for x when it's in the exponent. So in the last lesson there, when we were solving for x when it was up in the exponent, what did we do there, right? The only thing that we could do was graph it, right? We just graphed y1 and y2. We graphed one side, we graphed the other side. I'll go through that again just as a review in a second, but we were doing this graphical method. So that's one way of solving for x when it's in the exponent. The other way to solve for x when it's in the exponent is by rewriting the bases, and that's what this lesson's on. We're going to be rewriting the bases so that we can kind of solve for it directly and algebraically. And then the last way is going to be using logarithms to solve for exponents, and that's in the next after this quiz. We're going to be using logarithms to do it. Okay, so to make this work, what we're going to have to do quite often is we're going to have to change, well, numbers like this, like 9 to the power of 2x. We're going to change that to something, let's say, with a base 3. This will kind of make more sense in a minute, but just kind of bear with me. So what I mean by that is I want to write this as 3 to the power of something, right? So can you guys tell me what I could rewrite 9 as like 3 to the power of something? Yeah. 3 to the power of 2, right? So what I'm going to do here, I'm just going to rewrite that 9 as 3 to the power of 2. Okay? And then that is all still to the power of 2x. Yeah? And then do you guys remember what the power law for when I go a power to a power? What do I do with those exponents? You multiply them, right? So this would be the same thing as 3 to the power of 4x. Okay, let's do some more. So the next one here, let's write 125 to the power of 2 minus x as something with a base 5. So I can rewrite that 125 as 5 to the power of 3. Yeah, 5 to the power of 3. And then put it in brackets, right? Like that's what I pretty much always do. When I replace the number, I put it in brackets so I know that I replaced it with that. So 5 to the power of 3, and then that's all to the power of 2 minus x. Okay, so just be careful on this now because you could think about this as being in brackets on that one. This 3 needs to apply to both, right, when we expand that out. So this would be the same thing as 5 to the power of 3 times 2 is 6 minus 3x. All right, let's do another one. So this one, 8 times 16 to the power of x. Well, can we rewrite the 8 as 2 to the power of something? 2 to the power of 3, yep. And then times, and then 16 could be rewritten as 2 to the power of 4. And then that was like times the x, so 4x. And then what do you do with the exponents when you're multiplying? Yeah. We add them, right? So we can rewrite all this as 2 to the power of 3 plus 4x, and that's we just have to leave it that way. 3 plus 4x. We can't combine those because they're not like terms. Okay, now they get a little different. Not too bad though when we've got them in the denominator. So for this one, we can write 512. We could rewrite this as 1 over, and then 512. You might not know this one offhand, but that'd be the same thing as 2 to the power of 9. Get you the 512. And then that is to the power of 3x. Okay, so that'd be the same thing as 1 over 2 to the power of 27x. Right, just multiplying that. The power to a power. And then how do I'd like this as just 2 to the power of something though. Instead of 1 over 2. Yeah, what would I do here? Yeah, negative. That really is just like if I make that to a negative exponent, that would flip it back up to the top, right? That's just that reciprocal. So that'd be the same thing as 2 to the negative 27x. Okay, I think we're good. Let's move to the next one here because we'll be doing some of these as we go too. So now we're going to solve for x. So the steps for this is we're going to write each side of the equation as the same base, right? So we want it to be like exactly the same base on either side. If necessary, use exponent laws so that each side of the equation contains only one base. and then equate the exponents, and then determine the value. So I'll show you what I mean there. So let's rewrite, well, this is good, like 10 to the power of x plus 4. Can I rewrite this 1,000 as 10 to the power of something? Yeah. What would that be?
Power of 3.
Power of 3, right? So this would be the same thing. So I can rewrite this as 10 to the power of x plus 4 is equal to, and then 10 to the power of 3 times x minus 4. And you see how I put it in brackets there? That's a good habit, right? Because remember, it's 3 times all of that, because I'll have to distribute. And then, just looking a little closer at this now, if 10 to the power of this is equal to 10 to the power of this, can you guys see that, just through logic here, that my exponents must be equal to each other, right? If those things were going to be identical, like if this all ended up being like 10 to the power of 2, and this ended up being 10 to the power of 2, I have to be able to say that those two things are just equal to each other. Okay, so that's step number 1. We're good to go. So now we actually just make those equal to each other. So we'll say, okay, well then x plus 4 must be equal to 3 times x minus 4. And then this part is algebra that you guys have been doing for a long time now, right? So let's just expand the 3 out. So we'll have x plus 4 is equal to 3x minus 12. And then we end up with 2x is equal to 16. And then x is equal to 8. Okay. All right, you guys try. You guys try letter B, and then we'll work on that together. So I'll give you a hint here. The other ones I turned it into the same as this side. We might have to do something to both of them on this one. Okay, so if you're watching the video, there's the answer. You can pause it. Okay, so let's move on to the next one. And that's really the skill, guys. So it might get a little bit more difficult. The algebra might get a little bit harder, but it's all stuff you guys have done. The only kind of new thing that we're doing is just setting up those bases so that they're the same, and then it's straight algebra. So let's just do a few more, and then that'll be good. So, all right, let's do this one. So what can we rewrite this one as? So the 8 and the 4. Well, what do we think the base would be, by the way? So for 8 and 1 over 4, what could we possibly use for a base that'd be the same for both? 2. Yeah, I'm thinking 2. This one's in the denominator. I'll show you why that won't matter in a second. We'll be able to figure that one out when we get to it. But look at the 8 and the 4, and I'm trying to think of like some number that I can go to the power of something to get those two, right? So let's rewrite the 8 as 2 to the power of 3, and then times x plus 2. And then that's equal to, all right, so then 1 over 4, here, just over on the side here, that'd be the same thing as 2 to the power of what? Negative 2. You guys see that? So you could say that would be 1 over 2 to the 2, but then that would also be the same thing as 2 to the power of negative 2, right? So I'm going to rewrite this as 2 to the power of negative 2 times x plus 3. And then that's the new thing. I think you guys will be okay from there, right? So we'll make them equal to each other. 3 times x plus 2 is equal to negative 2 x plus 3. Distribute them in there. So we've got 3x plus 6 is equal to negative 2x minus 6. So we end up getting 5x is equal to negative 12. So x is negative 12 over 5.
What happened to...
Tricky. All right, D. Actually, you know what, guys? Let's see. Let's see if you guys can figure this one out. I'm going to pause it for a second. Talk to your neighbor. How does this one work? All right, so the problem here is this 1, right? Like, how do we deal with this thing? Well, what about this? Here's the little twist here. Why don't we call this 121 to the power of 0? right? Because anything to the power of 0 is 1. Yeah, okay, so I can do that, and then this side would be 121 to the power of 2x minus 5. All right, so then now we're good, right? We got the same base. So now we can actually just say, okay, well then 2x minus 5 is equal to 0. So then x would be equal to 5 over 2.
Where are you getting 4 and candy from? 4 10 looks like.
Okay. And then this one, this will be like another, kind of little twist. So looking at this one, you might start being, okay, what's a number that, like, for 9 and 7 maybe, it doesn't really look great. But what you should always do, like this 21 is really my issue right now, right? This doesn't look right. That 21's a problem. Any idea how I can get rid of that 21 on the one side? Yeah. Yeah, take it to the other side, right? Let's see what we got going on. If I divide both sides by 21, then we can, okay, go divide by 21 and then divide it by 21. This looks kind of promising. Let's rewrite it. So that'd be 1 over 9 to the power of 4x is equal to, can you rewrite 7 over 21 a little simpler?
1/3.
Yeah, 1/3, right? This is looking better, right? So 1/3, 9 and 3, I can work with those. Those seem like I can use a base 3 now, right? So what can I rewrite 1 over 9 as? That would be the same as 3 to the power of -2. Yeah, good. -2 times 4x. And then that's equal to 3 to the power of -1. Yeah, -1. Okay, good to go. All right, now I can set them equal to each other. So -2 times 4x is equal to -1. So that would be -8x is equal to -1. So x is equal to 1 over 8.
That's really satisfying.
Okay, so an example of this, a bacterium triples every 6 days. The number of bacteria n present after x days is given by the formula n is equal to 3 to the power of x over 6. After how many days are there 243 bacteria? So really we're solving for x here, right? And they've given us n. So let's write it in. So that'd be the same thing as 243 is equal to 3 to the power of x over 6. Now, the other way we could solve it, right? We could graph it. We can always graph it, right? We could graph, y1, y2, figure out where they cross, and that would do it. But let's use our method we just learned there, right? So 243, well, we could rewrite that as 3 to the power of 5. I don't expect you guys to memorize those, but you might just try some things out, right? You might have to do a bit of searching to find that if you weren't sure. Okay, so 3 to the power of 5, and that's equal to 3 to the power of x over 6. Okay, good to go, right? So then I can equate the exponents. So 5 is equal to x over 6. So x is equal to 30. So that's really it, guys. Just again, so we've been kind of doing this in the last lesson already, but just as a reminder for graphing, right? You can set the two sides equal to each other. Or you can get everything over to one side and set the other side equal to 0. And then you're looking for your x-intercepts. You guys are okay with that one? Yeah? Okay, so I won't spend any more time on that because we did that last time. And then this is just, how would you solve this if you were going to do it in your calculator? Well, you would just graph this side as y1, this side as y2, and you'd be figuring out where they cross, right? Yeah. Okay. Yeah, like I said, I'm not going to get into it though. We will be in the next lesson there, figuring out how to solve things like these algebraically, right? But that's going to take logarithms.